Okay, our bad-up speaker, we're very pleased to have Jim McDaniel. He's the Senior Assistant General Manager of the Water System at Los Angeles Department of Water and Power. He got his degree in engineering from the University of California, Irvine, but has a lot of experience. Served as Director of Water Quality and Operations, Manager of Water Systems and Operations. More recently, though, he's been involved in national level, looking at water security, and he works with the American Water Works Association and serves to link the industry with research. He's really focusing on this future, and you can see from his title, Water Reliability 2025. So he's going to wrap us up with this, how he's going to take all this science towards implementation.
Wow, I'm up here with quite the august group. Have no PhD, so bear with me. But I think I have maybe some interesting things, some applications. LA Department of Water and Power is a part of Renew It, and every time I get a chance to go up to Stanford and meet with Dr. Sedlak and his grad students, it kind of makes my head explode, all the interesting stuff that they're doing up there. So I want to talk to you today about how we're going to address water reliability for LA Water Reliability 2025. And just let me, I don't have the usual slide up here that says where LA is and how many people, but I work for the LA Department of Water and Power, which is a part of the city of Los Angeles. So we serve basically the city of Los Angeles, which is almost 4 million people spread out over about 460 square miles. So it's a fairly large utility, but a lot of people get us confused with Metropolitan, which is even larger. They're the wholesaler that serves everybody from the Ventura County to the Mexican border. So we're just the city of LA. And we've got a new initiative to accelerate our development of local water supplies. We've been working on local water supplies for a lot of years now, but because of the things that we just heard, climate change and these other issues, there's this new sense of urgency. So we're looking at trying to accelerate some of these things and have them in place 10 years before that we had originally planned. Now, what I'm going to show you today it's a work in progress. This was something our previous board had asked us in city politics when we have a new mayor. Mayor Garcetti is in. When you get a new mayor, you get a new board. So the previous board had asked us to develop this plan, but the new board hasn't implemented it yet. So what I'm sharing with you, I told the staff, stamp draft on all the copies, because if something happens here, I don't want to get held too accountable for this. But I'm pretty sure that this is along the lines of the direction, probably even more so. I'm guessing most of the questions I'm going to get asked is, can't you make that Water Reliability 2020? So here we are, the state of California. These are the major water supplies that we have for the city of LA. Over 85% of our water is imported. Most of it through the State Water Project. We also have the LA Aqueduct and the Colorado River all add to our imported supplies. But our future is going to be on local resources from groundwater, stormwater, recycled water, and conservation. So here's a little history of some of the proactive water resource development that we've done in the city of LA. We began in 1913 with the LA Aqueduct number 1. That's one of those water 1.0 projects, I guess. Approximately 30 years later, we had a big hand in the Colorado River Aqueduct in 1941. Then another 30 years later than that, we built the second LA Aqueduct, which was done in 1970, and the State Water Project in 1972. And that was pretty much, I think, the end of that Water 1.0 for LA. That was the end of the big aqueducts. And since then, our focus has been on local resource development. So let's take a look at back when I kind of started at the Department of Water and Power 30 years ago. Where were we back then in the early 1980s? Well, Metropolitan Supply was about 1/10 of our overall supply, and we got LA Aqueduct supplies made up, and the LA Aqueduct supply made up 80% of our retail demand at that time. But today, half of our LA Aqueduct supplies have been reallocated to the environment in the Eastern Sierra. Our groundwater production has been cut in half due to contamination, And our MWD reliance has increased so that now we're buying over half of our water from Metropolitan Water District, most of that coming from the impaired Bay Delta region. So we've got these new challenges. Contamination threatens to suspend pumping on our San Fernando Basin wells within 5 to 10 years. Urbanization has decreased our natural stormwater infiltration. Our purchased water costs are continuing to rise, and we have threats on our imported supplies due to Delta ecosystems declines, these LA aqueduct issues I mentioned, so that half of that water that we're not getting from the Eastern Sierra and the LA aqueduct, where did that go? So we're using that, we're refilling Mono Lake, we're rewatering the part of the lower Owens River below the point at which we diverted the Owens River into the LA aqueduct. We're using a lot of water right now to control dust on Owens Lake to address an environmental problem there. And so that's where our LA aqueduct supplies are going. We've got a long-term drought on the Colorado River. We realize now that the Colorado River was allocated, all the water on the river was allocated in probably a historically wet period of time, so there's really not enough water to go around when you stretch that out over the long term. And then climate change, and we just heard a lot of the implications for climate change on all these different systems. So our Water Reliability 2025 is going to be achieved by a two-pronged effort. One is enhancing our local water supply development through capturing stormwater, enhancing our water conservation, and reusing our water recycling program. So capture, conserve, and reuse. But in order to do that, we're going to have to deal with remediation of the San Fernando Basin groundwater, which has been severely impaired due to contamination. I'm going to talk a little bit more about that in a few minutes here. So the current conservation program, let me talk about that a little bit. The conservation program in LA began in 1977. The key programs include the adoption of local ordinances that facilitate the efficient use of water, the rebate and incentive programs for our residential and commercial customers, public awareness programs to help educate our customers, and partnership programs with other city departments and Southern California Gas Company. Currently, we're shifting the emphasis from indoor water conservation to more external water conservation. You heard Dr. Sedlak talk about the need to come up with better ways to irrigate. In our service area, when you look at the residential sector as a whole, approximately 40% of that water, remember that's all treated to that same one-size-fits-all treatment scheme, is going to water plants outside. When you look at just the single-family home sector in our service area, it's probably more like 60% of the water is going for irrigation outside. So we're looking at programs like currently we've got a program to pay people to remove lawn, which is probably one of the most water-intensive types of landscaping you can have, and we'll pay $2 a square foot for people to remove lawn and put climate-appropriate landscaping in that's actually quite beautiful and very appropriate for the area, and it saves the customers a lot of money. So over the time, and I appreciate the kudos to the conservation program that we had. We're very proud of this. We've got a population increase in LA since 1970 of approximately 1 million people, yet you can see that our water demand is remaining pretty much flat. LA residents use about 123 gallons per person per day. That's averaged over all classes and all uses, just the total number of gallons divided by the total number of people. And for U.S. cities over 1 million people, that was the, believe it or not, that was the lowest water consumption in the United States. I was talking to a group the other day, and actually I got a question at the end of my talk, and it was a guy, and he says, "Excuse me, I think you had a mistake on your slide. You said 123." And this was somebody from, I think he's from Australia, so he probably said, "Excuse me, mate, you got a mistake on your slide. You had 123 gallons of water per person per day. I think you meant liters." And I go, "No, unfortunately, I did mean gallons." But I think just like with crisis and opportunities and that sort of thing, when I look at that, even though we're proud of this record, I look at what water use in Europe is, water use in Australia, there's a lot of room for us to go. So a lot of people have kind of said, well, you know, we've pushed water conservation as hard as we can go. We need to focus more on recycling, stormwater capture. But I say, no. There is still a lot of room for us on efficiency, and we need to not lose sight of that. We've spent over $250 million on water use efficiency since 1990, and it's resulted in a cumulative water savings of over 100,000 acre feet per year from where we would have been without that kind of a program. So on the recycling front, we've been recycling water in LA for over 30 years. We feel that recycled water is local, safe, and a reliable water source. About 20% of the wastewater treated at the City of LA's plants is beneficially reused. Now, not all of that is offsetting potable supply. A lot of that has to do with supplying to lakes and rivers and environmental uses, but it is being beneficially reused. But our goal is to increase sevenfold the amount of water that either would replace potable demand or supplement potable demand, going up from about 1% today to almost 8% by 2025 in this plan. So that's going from about 8,000 acre feet per year today to 59,000 acre feet per year at the end of this plan. A key part of our program is going to be groundwater replenishment, very similar to the project that's existing here in Orange County. Unfortunately, the plant, a lot of this is very location specific. The place that we have where we can do this in the San Fernando Valley, we just don't have enough sewage effluent, or I'd probably build a bigger plant. But we're looking at doing about 30,000 acre feet per year of groundwater replenishment. And we've started our environmental process on that just this last September, and we're collecting public comments. And we've been doing a lot of research. We're taking lessons from Orange County. Mike Marcus has been extremely helpful in guiding us. And if you get a chance, if you haven't been through his plant, as I tell everybody, I go, take the tour, drink the water at the end of the tour. It's because it's a wonderful plant and it's a wonderful thing. So I hope to have my own plant where I can give people the tour and they can drink the water at the end of it. Purple pipe, we've got about, we haven't given up on purple pipe, but I really think going forward, potable reuse projects are probably going to be where the big bang for the buck is and where we're going to be expanding water use going forward. Interestingly enough, there's, you know, even with all this good stuff going on, there's still competition for this. We've got this big desire in Los Angeles to restore the LA River, and the mayor is really big. He's been to Washington. He wants to get money to restore the LA River. The problem with the LA River is, because I grew up I spent my whole life probably within a short walk of the LA River. And the LA River, there really isn't much of a LA River for 330 days of the year. It's mainly there to collect stormwater that we get. You know, we get 80% of our precipitation in 12 days in LA. So what you've got on the LA River now is tertiary effluent that we haven't yet developed the capacity to recycle. So now there's going to be competition for that amongst people that want a riverine type environment, and those of us that want recycled water. And the funny thing is, a lot of the people that are advocating, they want both of them. So we're going to have to figure this out, and we're working through it, and we've actually kind of saw this coming a long time ago. We did a programmatic environmental document. We have allocated water for the river and water for recycling, but it's going to be very interesting to see how that plays out going forward. I want to talk about stormwater capture. I want to talk about both centralized stormwater capture and decentralized stormwater capture. On the centralized side, we have 5 spreading basins. I've got Hansen spreading grounds pictured here. The Tujunga, Pacoima, Lopez, and Brantford. We have 3 large dams, Hansen, Pacoima, and Tujunga. And we've been working with the LA County Flood Control District recently to combine our efforts and kind of get out of our bureaucratic silos and look at exchanging money and resources and other things to do more with these facilities. For a long time, the county, they've been operated purely as flood control facilities. But the reality is that going back to a decision on Pueblo water rights, all the rainfall that falls in the whole ring of mountains around the San Fernando Valley belongs to the city of LA. If it flows into the LA River and flows out of the city of LA down to the ocean, well, too bad for us. But if we can capture it and keep it in the groundwater, that's free water for us. And for the longest time, we were kind of oblivious to that. We were focusing on water 1.0. We're like, okay, we need to get more Bay Delta water, we need to get the Colorado River water, and we were really ignoring this great resource that we have. So we've changed our mindset, and because we get 80% of our water in only 12 days. These centralized projects are still a big part of the plan for us. We haven't given up, or we're not paying attention to decentralized, but due to the nature of the way the rain falls, this again, we're looking at rates, we're looking at monetary resources. Where's the most bang for the buck? And so centralized projects that we have a lot of this infrastructure in place, and a lot of it just depends on rehabilitating it, cleaning out. For instance, these stormwater capture facilities are up in the mountains. We have these big wildfires in the Santa Monica Mountains. The ash from the fires comes down, it fills these basins up. The county doesn't have the money to dig the basins out, so they do the bare minimum that they can do for flood control. 80% of the basin is there. If somebody had the money to dig it out, it's available for stormwater capture. So we're kind of in the business now. Our stormwater capture is demucking some of these basins out, and it's got a huge return on investment for us. On the distributed side, we're looking at these small neighborhood projects at the residential level, at the street level, and we're trying to look at projects specifically where we can offset potable demand through stormwater harvesting, but we're also cognizant of the runoff benefits that these have. I've got a picture here of what they call the Elmer Avenue retrofit, which is consists of an infiltration gallery, perforated pipes installed into the street to collect the stormwater for recharging our local groundwater basin. There's a bioswale there that was built as part of the new sidewalks. That it's an open, shallow channel, so instead of having the water run down the gutter to the storm drain to the ocean, it kind of diverts into this bioswale and it gets captured. And basically, you've got a situation now where all the water, not only on this street, but the streets surrounding it that used to kind of get funneled through it, all that water is captured now. It's put in the ground. It's not running off into the storm drain system, and it's not creating this urban runoff problem. Now, to do this on a large scale, we do have some concerns about the contaminants that are on the street, what happens to all that stuff, what's the fate and transport of that, and this is one of the things that we're very interested in working with Renew It on, trying to make sure that as we go through these kind of projects, we don't create some unintended consequence or some other kind of problem. Groundwater remediation. David Sedlak mentioned the managed aquifer concept, and this is really important for us because our San Fernando Basin represents 80% of our groundwater rights. 57 of our 115 groundwater production wells in the basin are now off due to contamination. So that's half of our entitlement cannot be pumped. We estimate that the plume is moving and that within 10 years we'll have lost the entire basin if we don't do something. So we're looking at a groundwater system improvement study, or we're conducting a groundwater system improvement study, and basically what we're going to end up having to do is build treatment on the production wells so that when we pull this water out, we treat it, get rid of the contaminants. Over time, it will help clean up the basin, 300 years, 500 years. I don't think we have time to do that and just wait for the basin to clean up, so we're going to have to aggressively treat the water that we pull out. We estimate that the facilities to do that are going to be expensive. They're going to cost between $600 and $900 million. But we think that it's well worth it. And the reason is that having a basin that we can manage and actually use, that's the key to both of our stormwater capture element of our water supply plan, because you can capture all the stormwater you want, but as a drinking water guy, that's great if you take it off the street and everything. But if I can't put it in the basin, then pump it back out and serve it as water to my customers, it's kind of hard for me to justify doing that from a drinking water utility perspective. If I want to do groundwater replenishment with recycled water, I put it in the basin, and then you pull it back out, you got to be able to use it. So this thing, and then also just storage. We have wetter wets, drier dries. We need to be able to store the water when we have it, and we need a place to store it. The groundwater basin's a perfect place to store it, but again, you need to be able to use it. So this strategy is going to be key to it's kind of the linchpin to all the other local supply strategies, and it's going to be very important for us going forward. The good news on that is when you run the numbers on this and what's the cost benefit, and I'm going to get to that on my last slide, it looks like it's going to be a good investment for us. So if we do all this stuff, what's the picture look like in 2025? We'll be able to cut our MWD reliance about in half, from 52% to 25% by 2029. Our decreased dependency on imported supply will be a result of our development of this recycled water, stormwater, water transfers. I didn't talk about water transfers too much, but that's another piece of our portfolio where we're going to be building the capacity again, anticipating. Yeah, overall it's going to be drier, but there's going to be some periods where there's going to be a lot of water in the system, and we need to have a way to capture that. We want to take advantage of public-private partnerships. We want to take advantage of market conditions. So we're building transfer capabilities so we can move water better for a willing buyer, willing seller, no environmental impact type situations. We're looking at an additional 55,000 acre-feet of conservation above and beyond the 100,000 acre-feet that we already have in place, and that we'll need to have this groundwater remediation complex completed. Now, I know the focus on this is on local supplies, and everybody wants to talk about that, but I'm going to put a plug in for the Bay Delta Conservation Plan, because you can see that even going forward, we still have a tremendous exposure on our imported water supply. Our imported system, we can't walk away from that. We need to invest in that. We need to keep that reliable. So we're also very interested in seeing the Delta, some sort of fix get put into the Delta that allows us to reliably and environmentally responsibly export water and keep that as a part of our overall plan. One of the things we've been doing on this in recent days is doing a lot more rigorous economic analysis on these things. We've costed all these different projects out. We've run cost curves on them. What's the payback period, comparison to met costs? Now, this isn't going to make some venture capitalists in Silicon Valley get all gooey-eyed, but from a public works perspective, these things make sense. They have a positive rate of return. They do pay back eventually, which is about as good as it gets in the water business. So we feel like we can go to our customers. This is going to be more expensive. It's going to require rate increases, but we can go back to say to them, this is a good thing. We need to invest in this. This is going to help us out for our future. It's going to help build our economy. It's going to make businesses feel comfortable moving to our area. Just like William Mulholland, when he built that aqueduct 100 years ago, I think they only had need for about 10% of the water at that time. But these guys had vision, and they're looking forward. So just like we had that as our legacy going forward in our future, we need to have a vision for what this water is going to need to do for us, that it needs to be environmentally responsible, and that it needs to provide for our future. So we've got a lot of different plans and documents, and you may hear about these things. We've got our detailed master plan studies. We have this Water Reliability 2025, and then our Urban Water Management Plan, which is a document that in California all the major water utilities are required to do. So our 2025 document will be a living document. We'll be utilizing the findings from our Stormwater Capture Master Plan, our Water Conservation Potential Study, which is something that the energy side has done for a long time. I think ours is the first large-scale water conservation potential study that will have ever been done. And our groundwater system improvement study, and our recycled water master plan. So we've got all these detailed planning documents. They're all going to fit together, and then they'll feed into our urban water management plan, and hopefully we'll have reliable water for everybody in 2025. Thank you.